question from complex analysis that came last year in GATE. The question is C be the ellipse consisting of complex numbers such that z minus 2 modulus plus z plus 2 modulus is equals to 8 travels counterclockwise. We need to find the value of contour integral. Z minus 2 modulus plus z plus 2 modulus is equals to 8 means the sum of distances from a particular point z to the points 2 and minus 2 is actually 8. So this is an ellipse with foci 2 and minus 2 and the length of major axis is 8. So all the points which lie inside the contour are having the distance sum less than 8, because the points which are on the boundary are at the distance of 8 when taking sum of the distances from 2 and minus 2. So the points which are inside the contour will be having the distance less than 8. So this is the criteria to check whether the pole reside in the contour or not. First of all, we need to find the poles. For this, denominator z square minus 2z plus 2 can be written as z minus 1 square plus 1. For poles, denominator will go to 0. And we'll be getting the points z is equals to 1 plus iota and 1 minus iota. So these are the poles. Now we need to check whether they lie inside the contour or not. So for this we'll substitute the point 1 by 1 in the equation of the ellipse in place of z. If the points lies inside the contour, they will have the distance less than 8. So I'm substituting 1 plus iota in place of z. After substituting, the value of modulus will be as square of the real part plus square of the complex part and square root. So it is 1 square plus 1 square square root plus 3 square plus 1 square under the root, and this comes at root 2 plus root 10, which is approximately equal to, like root 2 is 1.4 something, root 10 is 3.1 something, so exact value will be around 4.5, which is exactly the less than 8. The distance is less than 8 means the point lies inside the contour. Similarly, we need to check about the other pole, whether it lies inside the contour or outside the contour. So for this also we'll substitute 1 minus iota in place of z in left hand side of the equation, and this value also comes out as root 2 plus root 10, so strictly less than 8. So both the points lies inside the contour. We need to find residues at both the points. Now the value of the contour integral is given by is equals to sum of the residues at all the poles multiplied by 2 pi iota. That is why we need the residue part. So this is our contour integral. This will be given by 2 pi iota multiplied by sum of the residues of all the poles that lie inside the contour. Right? So we need to find residue at both the poles, as both the poles lies inside the contour. So for residue part, z is equals to 1 plus iota, we need to take limit z tends to a, z minus a, f of z. This is the formula. A here is the point 1 plus iota. And while writing f of z, we'll write denominator as the factorized part. Z minus 1 plus iota and z minus 1 minus iota, which are the roots of the denominator. So by cancelling out one part and substituting the limit, we get the answer as 2 iota upon 2 iota, which is 1. Similarly, we can find the residue at other pole. Limit z tends to that particular point, z minus that point, f of z. After cancellation and substituting the limit, we get here minus 2 iota upon minus 2 iota, which is again 1. So finally the calculation of contour, that is given by 2 pi iota into sum of the residues, and residues we have found as 1 and 1 on both the poles. So sum will be 2 and answer is 4 pi iota. So correct option is C, 4 pi.